Look at this question. The cut-in voltage for each diode in the circuit shown below is V gamma is equal to 0.6 volts. Each diode current is 0.5 milliampere. The values of R1, R2 and R3 respectively will be. See, in this, the equivalent circuit of diode is by means of an ideal voltage source. V gamma is given as 0.6 volts. Okay. Now what they are saying is the diode currents are same. Each diode is offering a current of 0.5 milliampere. zero point 0.5 milliamperes of current is flowing through each of the diode. So that what might be the resistors, or the resistors R1, R2 and R3 are so chosen that all the diodes carry the same current. That's the idea behind it. So how do we do this problem? And here D1 is on. Let me change the color. Voltage across D1 is zero point 0.6 volts. Let me take this is D1, D2 and D3. Voltage across D2 0 0.6 volts and voltage across D3 is also zero point 0.6 volts from anode to cathode. All the diodes are in conduction because it is mentioned that each diode is carrying a current of 0.5 milliampere. All are conducting, means voltage across each diode is 0.6. Okay. Further, I can take the currents. This current is ID1 is equal to 0.5 milliampere. Here it is ID2. It is also 0.5 milliampere. This current is ID3, which is again 0.5 milliampere. So current through R2, it is ID1 plus ID2. ये क्या होगा हमको 1 मिली एम्पियर आएगा. और इधर करंट थ्रू R3 ये क्या होगा 1 मिली एम्पियर is coming from R2 and 0.5 milliampere is coming from the diode D3. So total 1.5 milliamperes. Like this we can write. Next, various voltages. What is the voltage at this point? Here the total voltage at this point with respect to ground, it is 5. So here the voltage is 5 minus 0.6 I can write, or if I write this as Vx, 5 is equal to 0.6 plus Vx, or Vx is equal to 5 minus 0.6, it is 4.4 volt. I need not write even Vx also, nothing to worry. I'm just mentioning it as 4.4 volt. And what about the voltage at this point? Again, if we write here Vy, then 0 is equal to 0.6 plus Vy. So Vy is equal to minus 0.6. That's it. Then we can do the remaining calculations just like that. So for finding R1, what we can write? 10 volts is equal to 0.6 volts plus ID1 into R1 plus 4.4. Right? If I take this particular part, this part, what we can write? 10 volts is equal to 0.6 plus ID1 into R1 plus 4.4. So ID1 is known. R1 is equal to 10 minus 4.4 plus 6. It's okay 5 by ID1. It is 0.5 milliampere. So it gives us 10 kilo ohms. So from 10 kilo ohms, we can easily understand that option A is correct. Nowhere we have 10 kilo ohm. Okay, without further calculations, we can conclude this way. Of course, in the exam, every time it may not be possible in that manner. Anyway, right, we got the value of R1. Next, let me take the second one, like this portion. That is, R2 is equal to 4.4 minus of minus 0.6 by 1 milliampere. I can comfortably write this way. R2 is equal to 4.4 minus of minus 0.6 by 1 milliampere. So it is 5 kilo ohms. Yes, here we can see that 5 kilo. And coming to the last portion, R3. For R3, let me take this portion. Okay. So R3 is equal to minus 0.6 minus of minus 5 by 1.5 milliampere. Almost you will get it like 5 minus zero point 0.6, 4.4 or 44 by 15. 44 by 15 means approximately 3 kilo ohm, or it comes to be around 2.93 kilo ohms. That's it. We got the values of R1, R2 and R3 this way. Okay, that's it. Next, look at this question. In the circuit of figure, diodes have cut-in voltage of 0.6 volts. The diode or diodes in on state is R. Okay, anyway, the circuit has two diodes and they are asking to find whether the diodes are in conduction or not. Is one diode is conducting or both are conducting? Just we need to find. How do we find it? Simply, if the just we need to look at the currents through diode and diodes D1 and D2. If those currents are positive, then definitely both are conducting. If current through a particular diode is negative, the corresponding diode will be off. That's it. How do we get it? Let me take this as node X and this voltage is Vx. Then KCL at node X. What we can write? Vx. Anyway, voltage across each diode means 0.6 volts and voltage across D2 is also 0.6 volts. So it is Vx minus of minus 0.6 minus 6 by 15 plus Vx by or Vx minus 0 by 20 plus Vx minus of minus 0.6 minus 5.5 by 8 is equal to 0. I took the node equation. Then further what we can write, Vx by 15 plus Vx by 20 plus Vx by 8 is equal to 6 minus zero point 0.6, that is 5.4 by 15 plus here 5.5 minus zero point 0.6, that is 4.9 by 8. Okay. So if you observe this, here I can write LCM is 120. 8Vx plus 6Vx plus 15Vx is equal to 5.4 into 8 plus 4.9 into 15 by 120. So 29Vx is equal to, if you calculate it, so just you need to check it with calculator, it comes around 116.7. So that Vx is equal to 116.7 by 29. Its value is 4.02 volts, approximately 4 volts. So if Vx is equal to 4.02 volts, then see ID1. ID1 means this current. What we can write? 6 minus 0.6 minus Vx is 4.02 by 15. It is positive, so nothing to worry. And what about ID2? It is 5.5 minus 0.6 minus Vx 4.02 by 8. It is also positive. So there is nothing to worry about it. Or it's not looking so good. They are not asking ID1 and ID2. They are asking which diode is conducting and which diode is not conducting. What we did here, we assumed both the diodes are conducting and I calculated the current through each of the diodes. Nothing else. ID1 is 6 minus 0.6 minus 4.02 by 15. It is positive, and ID2 is equal to 5.5 minus 0.6 minus 4.02 by 8. This is also positive. ID1, ID2 positive. What we did here, we assumed both D1 and D2 are on and calculated ID1, ID2, which are found to be positive. Okay, better you can write even here. Assume D1 and D2 on. Much better way to write the statement. Then we have seen the currents. If the current through a particular diode is negative, we might have concluded that that corresponding diode is off. But here, nothing to worry about it. Like this, we can do this problem. Next, see this. For the circuit shown below, each diode has V gamma is equal to 0.6 volts. RF is equal to 0. Both the diodes will be on if. What is the value of your Vs, so that both the diodes, let me take this as D1 and this one as D2. Both the diodes D1 and D2 will be on. Okay. Let me assume this voltage as Vx and this as node X. Okay. Then KCL at node X. First point is for D2 to conduct, ID2 should be greater than 0. I can write this current as ID2 and this current as ID1. So for D2 to conduct, ID2 should be greater than 0, which implies ID2 is equal to Vx minus 0.6 voltage across D2. It is 0.6 volts we can take. by 0.5k, it should be greater than 0, implies Vx should be greater than 0.6 volts. Of course, we do not know what is Vx. We need to see that later. Next, what about ID1? ID1 is equal to, here the voltage is Vs and here it is 0.6 volts. So, Vs minus 0.6 minus Vx by 5k, it should be greater than 0, which implies Vs should be greater than Vx plus zero point 0.6. Anyway, Vx is greater than 0.6 implies Vs should be greater than 1.2 volt. How I am saying so? If I take this as 1 and this as 2, 1 and 2 implies we can take it so. Okay, but that answer is not there. 1.2. Okay, it is also there. Interestingly, let it be. We'll see. And there is one more thing we need to check. What is it? Let me take the node equation. KCL at node X. If I take so, what we can write? Vx minus of minus zero point 0.6 minus Vs by 5k plus Vx minus 0 by 0.5k. Okay, or Vx minus Vs by 5k. See this. Vx minus 0.6 minus Vs by 5k plus Vx minus Vs by 5k plus Vx by 0.5k plus Vx minus 0.6 by 500 ohms. This is so. This is one relation among Vs and Vx. So what we can write here? Further, I can cancel k both the sides, and it becomes 2Vx plus 2Vx, that is 4Vx, and Vx by 5 plus Vx by 5, 2Vx by 5. 4Vx plus 2Vx by 5 is equal to Vs by 5 plus Vs by 5, that is 2Vs by 5 minus 0.6 by 5 plus 1.2. Like this we can write. 22 Vx by 5 is equal to 2Vs minus zero point 0.6 plus 6 by 5. So Vs is equal to, from this what we can write, Vs is equal to 11 Vx 5.4 by 2, 2.7. So that, then what is the condition? Vs should be greater than zero point 0.6. So as Vx should be greater than 0.6 volts, Vs is should be greater than 11 into zero point 0.6 minus 2.7. So 6.6 minus 2.7, it is equal to 3.9. This is our actual answer. Okay, earlier we got Vs is greater than 1.2, but that is not sufficient. Right? Okay, for ID1 and ID2 be greater than 0, we have got it. But we have one more condition which can be obtained by taking node equation. Right? By applying KCL at node X, we can see the exact relation between Vs, Vx and the final value of Vs. Okay, this is how we can do this. So option A is correct here. Right. See this question. Consider the given circuit and the cut-in voltage of each diode is V gamma is equal to 0.6 volts. What are the values of ID1, ID2 and ID3 respectively? Okay, current through each of the diode they are asking. How do we do this? If you observe the diode D1, its anode is going to 10 and cathode is going towards minus 20. It looks like D1 is on. And D2, its anode is going to 10 and the cathode is going towards minus 10. It looks like D2 is on. D3, its anode may be connected to ground, but the cathode is going to much negative potential minus 10. So it looks like all the three diodes are conducting. Assume D1, D2 and D3 are on. So what is our equivalent circuit? Yes, this is how we can take the circuit. Now what about voltage across each diode as they are conducting? 0.6 volts, 0.6 and 0.6 volts. This current is ID1 and this current is ID2. This current is ID3. Okay. We should get all the three currents to be positive. Let us find. And here, one thing we can observe, interesting point. What is the voltage at this point? It is 0. Let me take this voltage as Vx. Voltage at this point with respect to ground. Ground we need not set somewhere. Here we can see that ground. Voltage at this point with respect to ground is equal to 0.6 minus 0.6, that is 0 volts. This is the interesting clue point in this problem. So that we can calculate I. What is I? I is equal to 10 minus Vx by 10k, that is 10 minus 10 by 10 minus 0 by 10k, it is equal to 1 milliampere. Okay, fine. And what about ID1? ID1 is equal to, here it is 0 minus 0.6 minus of minus 20 by 10k. I am writing it directly, assuming that you are very good in networks. Okay, 0 minus 0.6 minus of minus 20 by 10k, it is 19.4, means 1.94 milliampere ID1. If you observe this, I is equal to ID1 plus ID2, but in which ID1 and ID2 are positive, then I should be greater than any one of ID1 or ID2, which is not so, means definitely ID2 comes to be negative. If I take ID2, I minus ID1, it is found, I need not calculate it, it is negative. Is it possible? No, not possible. Once the diode is on, its current from anode to cathode cannot be negative. It should be positive. Implies D2 is off. D3 and ID3 we need not calculate. First, once I started the problem, we understood that D2 is only off. Then we have to look at D3. I am redrawing the circuit now. 10 volts, 10k, minus 20 volts, 10k. This entire current ID1, this entire current ID3, it is 0.6 volts, 10 kilo. Okay, ID1 and IR one and the same. So what about ID1 here? 10 minus 0.6 minus of minus 20 by 10k plus 10k, 20k. So 30 minus 0.6, it is 29.4, 29.4 by 20, so 1.47 milliampere. Straight away I'm writing it. Next, what about ID3? 0 is equal to 0.6 plus ID2 into 10k minus 10. So what about ID3? It is equal to 0.6 minus of minus 10 by 10 kilo. 10 minus 0.6, it is 19.4, so it is 1.94. Sorry, 0.94. Okay, that's it. ID2 is anyway 0. Okay, this is how we can do this. Then we can even see the voltage here. Here the voltage is no more 0. What is the voltage here? 10 minus ID1 into 10K. Okay. So 10 minus 14.7. Whereas ID3, okay, we can calculate but not required. So if you look at the options, which one is matching? Option D is matching. 1.94, sorry, 1.47. Option C, 1.47, 0 and 0.94. That's it. This is how we can do the program.